So let's look at combining functions with the graph, and we'll even do a little more work with tables as well. So we have a graph on this right-hand side with this linear function f of x, and then this interesting function of g of x is kind of its own shape there. Alright, so where we can start is just filling in the outputs for these two functions by looking at the coordinates. So let's look at f of x first with linear. So if I want to see the output for x equals -5, I just think about the coordinate right there, which is occurring at -5. And then at -4, we're at -4. And at -3, we're at -3. And as we fill that out, we can realize we have this slope of 1 occurring. So the rest just kind of follows through. Since it's linear, it's just going to stay on that same pattern. So the outputs for f of x completely match our inputs. G of x will be a little more interesting. So at x equals -5, g of x is -2. At -4, we have an output of 3. And then we have this output of 3 up until -2. So we're going to see 3 and 3 again. Then we get to -1, we have an output of +1. At 0, +1, 1, 1. At 2, we have our output of 3. At 3, we have an output of 3. At 4, we're down here at -5. And at +5, we're at -5. So just going through and looking at the coordinates and grabbing those output values. Now adding the functions, it's really nice to do this in table format, because what we're going to do is just go through and add these numbers together. So it's like I'm putting addition between each of these numbers. So I'm taking f of x plus g of x. So for the first one, I would be taking -5 plus -2, which is -7. And the next one, -4 plus 3, -1. -3 plus 3, 0, 1, 0, 1, 2, 5, 6, -1, 0. So just going through and adding those outputs, moving down the table together. We could graph this function. What it would look like some interesting spots, like if we look at -1, we have this +1 output and -1 output. So the idea is if we add those outputs, we end up at 0. Or like if we were at, let's look at x equals +2. We have this output of 2 plus this output of 3. So that puts us up at 5. So it's adding these outputs together, and it's just when you have negatives, they kind of start to cancel each other out. It kind of turns into subtraction. But what you could do is graph this function and end up with this function that graphs how these two functions would combine through addition. Our next one is to look at subtraction. So what we're going to do is take f of x minus g of x. So it's like I'm putting subtraction between each of these pieces. So like for the first one, I'm doing -5 minus -2. So -5 plus 2, so that would be a -3. -4 minus 3 would be a -7. -3 minus 3 would be a -6. -2 minus 3, -5. -1 minus 1, -2. -1, 0. -1, 0. 9, 10. I think I did those quickly, but yeah, all good. Alright. So again, same thing with this. This would be looking at the difference in outputs, and it would be the difference starting with f and looking at the difference of g. So like out here at +5, it's this difference of +5 and a -5, and that's where it throws it up to +10 because we have this subtraction of a negative. So we have this distance of 10 occurring in terms of the difference between the two functions. Alright, I'm going to get those subtraction symbols out of there, and let's look at some function combinations. I'm going to zoom out a bit so we can see the whole thing. Alright, f of 4. So what I would do, and again if it helps, you just kind of make sure you see how your inputs separate from all the outputs so it doesn't get mixed up. So f of 4, I just look up x equals 4 and look for the value for f, which is positive 4. G of 4 at x equals 4, and then looking at g of x, which is negative 5. F of 4 plus g of 4, two ways you can go about it. You could just add those two numbers together, or these two pieces that we're going to look at next are the same thing. So you could think of it as a separation of 4 plus negative 5, which is a negative 1, or you could just jump over to where x is 4, what is f plus g telling us, which is negative 1. So those would do the same thing. G of 1 will give us 1, g of 3 gives us the 3. G of 1 plus 3, be careful with this one. This is that case where you can actually simplify first, that this is really just asking for g of 4. So if you have addition of the input values, carry out that addition or subtraction first. So g of 4, if you plug in x equals 4, g of x gives us a negative 5. G of 1 plus 3, we can take positive 1 plus 3, which is a positive 4. And with this one, it's not going to have a combined form like up above there because we have two different inputs. F of negative 3, so negative 3, and looking at f of x, which is negative 3. G of negative 3 would be a positive 3. F of negative 3 minus g of negative 3, so I'm taking a negative 3 minus a positive 3, so that's going to be a negative 6. Or that's going to be the same exact thing as looking at that input of negative 3 and looking at the subtraction of the two functions. So this is a case where those notations are actually asking us the same exact thing. G of 1, so we're plugging in x equals 1 and looking at g of x, which is positive 1. G of 4, looking at x equals positive 4. G of x is telling us negative 5. Again, here, be careful because we have this subtraction of the inputs, so we can simplify that that's just asking for g of negative 3, which is a positive 3. G of 1 minus 4, we would take 1 minus that negative 5, which is a 1 plus 5, so that would give us a positive 6. So that's how we can work with our graphs. We could graph these combined functions if we needed or wanted to. And then once we have these tables, we can do so much with looking at the function combinations all together and calculating different values.